In this more advanced exercise, we will use our knowledge of the Python data structures, list, dictionary, set, as well as our knowledge of the string data structure in Python to build a mini text analytics tool. We basically have an article from a news source, and we would like to do some processing and report some aspect, high-level analytics of the text of this article, such as counting how many words it has, counting how many unique words it has, and also sort these words by frequency. Once we sort the words by frequency, we will notice that many of these words are common English words which don't convey any particular meaning. So we would like to exclude these common English words. Let's take a look at these questions one by one. First, this is the article and it's a multi-line string, as we will see. Next, I'm just going to load these common English words, also called stop words. For instance, if you take a look at the stop words, you can see those are very common English words, but they don't have any specific meaning on themselves. Many often these words end up being excluded from text analytics because we're not interested in knowing how much the word will or the or are being uttered, right? We need to exclude these words. Okay, so let's start with the first two questions. First two questions are asking us to count how many words this text has, as well as how many unique words it has. So the first step is to break this text from being a string to being a list of words. Here we need to use the function split. So I'm going to create a variable called words, and I'm going to split article.split. Of course, this is a long list of words, so I don't want to dump it, all of it, but I just want to make sure it's done a good job splitting it. Okay, how many words we have? That's basically the length of words. And we have 606 words in this article. Now, how many unique words we have? Obviously, some of these words are repeated, right? So we need to take out these repetitions from this list. How do we do that? Well, we know that the set data structure ignores repetitions, repeated values. So what we do, we take the list and convert it to a set. So I'm going to convert the list to a set and I get a set of words. Obviously, I'm not interested in the set itself. I just want the number of unique words. I'm going to take the length of the set of words, and we can see that we have 418 unique words in this case. Okay, I'm going to call this one unique words because I'm going to refer to it in the next question. So I'm going to store it in a variable itself. The next question is asking us to sort these words by frequency. So sorting it by frequency basically implies counting how many times each word has occurred and putting it in a data structure. What's the data structure that is useful here? Well, since we want to associate each word by frequency, a natural data structure is a dictionary. So what I'm going to do, I'm going to create a dictionary called word frequency, and I'm going to start with a new dictionary here, a brand new dictionary. And then I'm going to initialize the dictionary. So I'm going to go for each word in unique words and create an entry in the dictionary. Frequency of word is equal to 0. This means that my dictionary has now an association between each one of the words in the article with the number 0. Next, I'm going to do the real counting. I'm going to go over each word in words, not the set, but the list now, because I want to count the frequency. So I'm going to do word frequency of word plus equal 1. That basically read it and add 1 when we encounter the word. So keep accumulating this, and my dictionary here, word frequency, has now the frequency of these words in the article. So some of them are not frequent, some of them are more frequent than others, as we can see. Okay. Obviously, I don't want to dump this whole thing into my notebook. I'm just checking that the results are okay, correct. Now, we need to sort this dictionary. And there is no natural way of sorting a dictionary. We know that we can sort a list, but we don't know that we can sort a dictionary. So what I'm going to do, I'm going to convert my dictionary to a list. So what I'm going to do, I'm going to use the function items. The function items is going to basically give me a dictionary in a list kind of like format, a list of tuples. Let's call this one a list items. Okay, so what I am going to do with this list, I'm going to sort it using either the function sort or the function sorted. However, it's important here to specify how we want to sort it, because we want to sort it by the frequency rather than the word. Now, if I do sorted here, sorted items, is going to sort by the first element in the tuple and then by the second. And since the first element in the tuple here is the word, I'm going to get an alphabetical sorting, which is not what I'm looking for. I want to sort each tuple by the second element. Hence, I'm going to write a key function. My key function here is going to take each item in the list, and each item in the list is a tuple. Now the tuple has two elements, the first one which is the word and the second one is the frequency. So I'm going to ignore the first element and I'm going to pull the second element which is the frequency. And I want my sort to be in reverse order, so I'm going to put reverse is true here. So you can see here that after I sorted, I get a list in which the word to is repeated 20 times in and the for a, so on and so forth. So let's call this one sorted items. And let's say I want to look at the 10 most frequent items. So what I'm going to do is to look at the 10 so I don't dump everything. I'm going to get a slice from my list from the beginning to 10 exclusive. So that's going to give me 0 to 9, 10 items here. Those are the most frequent 10 items in the list. Those are the most frequent 10 words in the text. Now what I have done here, sorting, counting, there is basically a built-in data structure in Python called counter that does that automatically. So we did not learn about counter here, we just used our knowledge of a dictionary. I'm going just to show you the use of counter because, I mean, this is such a common operation that many often it makes sense to use a built-in counter data type rather than re-implement it using dictionary. So counter exists in collection, so I'm going to import the class counter from collection, and then simply speaking I'm going to wrap the list of words to counter, and that's going to give me this counter object here. And I still need to sort it, but you can basically see that's the same idea as I can create the counter and I get the items of the counter here. And the remaining is the same, but basically it kind of circumvents us doing the loop and counting each element. Okay. So this is another way to doing it, just for illustration purposes. Let's comment out this code. Now let's go back to this list, and you can see that the first 10 words are common words, but they're meaningless words because they are just common English words. What I want to do now, I want to filter out these words using the list of stop words here. So I want to delete the words here if they are some of the stop words, and there are a couple of ways of doing this. One way to doing this is to reprocess the dictionary again, but do not count these unique stop words. So I can take a look at my unique words here and do the set difference minus stop words. And those are going to be the unique words that are not stop words. Okay? So what I'm going to do here, again, this is recreating the dictionary again, is to take that dictionary here. I'm going to call it word frequency 1 so that I don't delete the previous dictionary. Okay, so well, first step is to only look at important words. So I'm going to call this important word, important words. That's the set difference. And I'm only going to populate the dictionary for important words here. And then when I go for each word in words, this is important here. I'm going to check if word is in important words. Otherwise, there is no need to process here. Okay, so my word frequency 1 now is the dictionary that contains the important words. So The remaining things is the same. I need to take the items, sort, you know, everything else. So here, word 1, word frequency 1 dot items. That's going to be the same. And you can see here that I'm starting to see more meaningful words here. You know, says is probably not very meaningful, but you can see that some of the events, people's names, you know, issues have, you know, now they are surfacing here to the top. So I'm starting to get a better understanding of the summary of the text here. Okay, so the other way to do it is to process what we have. So we have word frequency. Why just recreating the whole thing? We can process word dictionary again. So what we can do, we can look at a sublist of word frequency here, so a sublist of sorted items. So sorted items are basically the words here. So what I'm going to do, I'm going to create another list called filtered items, which is going to be an empty list, and I'm going to go for each item in sorted items. Now each item is a tuple, as we can see here, so I'm going to check if item 0 not in stop words, because I don't want to put stop words here in filtered items. I'm going to put filtered items dot append item. So only append these items which are not filtered items. Once I'm done, I can take a look at my filtered items, and those are the filtered items, words that are not stop words. So we recreated another list using a for loop going over the original list. Again, sneak peek to next time, we can compress this in what we call a list comprehension. So let's convert this. Let's delete this line so we can see them in the same screen. Let's do a list comprehension. Basically, I want to create a list from an item for item coming from sorted items. Okay, basically we'll create the same list. It basically says go over each item in sorted items, put it in a new list. But we can have an optional if saying that if item 0 not in stop words, and this basically will filter out only these items in which the first component, again, don't forget each item is a tuple, so the first component is the word here, not in stop words, and I get the same result here.